Scenario. The figure shows a 4 kilogram mass hanging from a spring that is attached to the ceiling. The block is oscillating at 5 Hz that traces out a wave. Question. Determine the period of the oscillating mass. The answer. The period t is equal to 1 over the frequency, or the frequency is 1 over the period t. Here we are given that the frequency is equal to 5 Hz. So you're going to use the first formula. T is equal to 1 over f. Plugging in f is equal to 5. So the period here is 1 over 5, which is equal to 0.2 seconds. The period represents the time it takes to complete one cycle. So this oscillating mass is completing one cycle in 0.2 seconds. Question. Determine the spring constant of the spring. You can round if you would like. The answer. The equation that we use is given in the AP Physics 1 formula sheet. Period t is equal to 2 pi square root m over k. This is for the oscillation of a mass due to a spring. We can now divide 2 pi over to the other side, square to get rid of the square root, multiply k to both sides, giving you k is equal to m divided by t over 2 pi, which is squared. This is how you solve for the spring constant for the spring. You can plug in the values, getting you roughly 1.1 times 10 to the 4th Newton meter, or exactly, which is 3,947.84176 Newton meter. That is the spring constant for the oscillating block.